Hello friends, in my last session I told you earthwork, estimation of earthwork in a road project, and there I told you that the cross-section of the road is generally in the shape of the trapezium. It can be either in cutting or it can be in filling. If it is in filling, then the cross-section is like this. You have depth of filling D, this is the natural ground, and these are the side slope. Side slopes are generally 2:1 or 1.5:1. It depends upon whether the road is in cutting or in filling. Now let us say it is S/1. If it is in cutting, then this is a depth of cutting, natural ground surface, and here also I assume that it is S/1. 1 vertical in S horizontal. That is the meaning of S/1. Value of S can change with the type of soil. In my last session, I told you one method, that is mid-sectional area method. And in that method, what I told you that if you have a road of, let us say, length L, then in that case, we consider the depth at the middle of this length, and this length is generally one chain 30 meter, and this depth is taken because there is a longitudinal slope on the formation level, and therefore depth will change every meter. So in the mid-sectional area, what we consider depth at the midpoint of two ends of the chain length, and chain length is 30 meter. Today I will tell you another method, that is mean sectional area method. Now here, instead of taking average depth here or mean depth here at the center of the chain length, we consider the average of two areas. So you have a chain length of, let us say, L, and this is the area 1 here, and that is the area 2 here. And area of this trapezium is, let us say, this is the formation width B at the top or B here at the bottom. This is the depth. So this will be S into D, and here also on this side it will be S into D. So the total area of this trapezium is B plus this width here, B plus B plus 2S into D divided by 2 into D. Or you can say that B into D plus S into D square. That is the area. B is the formation width, D is the depth of cutting or depth of filling. S is the side slope, S/1. Now in mean sectional area, we consider area average of these two areas. So A1 plus A2 divided by 2 is the area or mean area. Average of two areas at two ends of the, so if you have, let us say, length 100 meter or 120 meter, divide this length into chain length 30 meter. So you have a profile here, that is the starting point 0 at 30 meter, 60 meter, 90 meter, 120 meter. You have area 1, area 2, area 3, area 4, area 5, and it goes on. So the first A1 plus A2 by 2 multiplied by chain length. Now this is the chain length, and I told you chain length generally is 30 meter, plus A2 plus A3 by 2 multiplied by again chain length, and that continues. So this is how we determine the earthwork by mean sectional area. Let me explain this method again, and I will take the same example which I considered in my last session for mid sectional area method. And example is like this. Calculate the quantity of earthwork for 150 meter length of a road in a uniform ground. The width of formation is 10 meter. Depth of embankment at zero chain is 2.5 meter. The longitudinal slope is 1 in 100. Chain length is 30 meter. Side slope is 2:1. Question is to find out the quantity of earthwork. So this is the natural ground, and that is the profile of the formation level. Now here at zero chainage, the height is 2.5 meter, and then you have 30 meter, 60 meter, 90 meter, 120 meter and 150 meter. Now here, because the slope in the longitudinal direction is 1:100, so for every 30 meter, this is 30 meter, 30 meter, there will be drop of 0.3 meter. So if this is 2.5 depth, it will be 2.2, 1.9, 1.6 meter, 1.3 meter, 1.0 meter. Now here, in this case, we will find out what is the area at this point, and then take average of these two areas. So you can prepare a table like this. At section, let us start with 0. Then next section is at 30 meter, 60 meter, 90 meter, 120 meter and 150 meter. So you find out what is the depth, H. Depth of cutting or depth of filling. Here is the filling because ground level is below and at the formation level. B is given 10 meter. Side slope is 2:1. So this depth is 2.5, 2.2, 1.9, 1.6, 1.3 and 1.0. Find out the area. Now area will be, as I told you, area is B into D plus S into D square. Now you know D is 2.5, S is 2, calculate the area. You can do it in two parts also. Find out B into D and then side slope S into D square and then add. So area here will be 37.5 meter square and 12.0. Now you take the average of areas. So take average here. That is average area. Next column. So average of first two, that is 34.59. That is mean average method. Okay, mean of these two. Similarly, next two values, 31.68 plus 26.22 by 2, and that is 28.95. Similarly, you do it, and 14.19. Now you have the mean area, multiply this, the chain length, that is 30 meter. So you get the quantity. Quantity in cubic meter. Quantity you can find out by multiplying this average area by chain length, and chain length is 30 meters. So 34.59 to 30, that is 1037.7 meter cube. 868.5, 710.10, like that. And you can take sum of all these values, you get the final total earthwork is 3604.5 cubic meter. This is the earthwork in 120 meter length of the road. And if you compare the first method, that is mid-sectional area method, in that case we got this value 3597. 3597.75 meter cube. So you can see that there is not much difference between the two methods. It is only the change of the procedure. In one case, you are taking mid-height. In another case, you are taking average of areas. So this is the mean sectional area method. Here, I have taken consistently that the road is in embankment. But there may be cases when the road is constructed in embankment, but in a certain length, it passes through embankment to cutting or from cutting to embankment. Let me just take one more example. Let us again consider a road from chain edge 0 to 4, and again the length of each chain edge is 30 meter. So 30 plus 30 plus 30 plus 30, that is 120 meter. RL of ground is given in meter, 70.9, 71.25. It is not a level ground. RL of formation at the first point is 70.30, and the road has an upward slope of 1 in 200. So let us calculate how much is the amount of earthwork in cutting and in filling. Taking a very short example of 120 meter, but it can be a longer also. So again, we make a table here. That is your chain is RL of ground. So chain is 0, 1, 2, 3 and 4. RL of ground is given 70.9 meter, 71.25, 70.80, 70.45 and 70.20. RL of formation. So RL of the first point is 70.30. This is given, and now you have an upward slope of 1 in 200. So in 30 meter length, the gain will be 0.15. That is 30 upon 200. 0.15 meter. So 70.3, next point will be 70.45. This will be 70.60. This is the RL of the ground, RL of formation. So there is a cutting. So depth of cutting, you can say depth. Here it is -1, -0.6, -0.8, 71.25, -70.45, then 70.8 minus 70.6 is still in cutting, 0.20. Now this will be 70.75. Now here it is entering into the filling, because 70.45 is now lower and 70.75, the formation level of the road, is at higher elevation. So somewhere in between these two, it will enter into the banking or in filling. So we just enter a new point here, let us say 2A, where we just say 0, 0 here, and this is the point where it is intersecting 0. Now next point will be 70.9. Now you can calculate area. Area is BD plus SD square. The side slope, okay, the B in the question is 8 meter and S is 1.5. So you can calculate B into D plus SD square here. So this BD will be 4.8 plus this will be 0.54. So total area is now 5.34 meter square. Similarly, for the next case, this is 6.4 plus 0.96. This is 7.36 meter square, and for this it is 1.66. Now here is the point where it passes through the level. So you have a profile of the road which is going up, and you have the ground level from 70.8 to 70.45. It is going below. So this is at 70.8. This is at 70.45. This point is 70.60 and this point is 70.75. 70.75. So you can find out what is this length. This is length is, let us say, L. So L upon difference point 2 is 30 minus L upon difference point 3. So L will be 12 meter. So from this point at a distance of 12 meter, this road and this formation level of the road will coincide with the ground level. That is in the level now. So this is 0. Area at this point is 0. So you can take 0 here. Now in the next column you take the mean area. Mean area. Mean area is average of these two values. So this is 6.35. Average of these two values is 4.51. Then average of these two values is 0.83 meters square. Now you have this one. So for this, the positive now, it is now positive, 0.30. Positive. This is 2.4 plus 0.18, so 2.58. Now this will be the average of these two values and this is 1.29. Next is plus 0.60 and this value is 5.6 plus 0.98. So this is 6.58 and you take average of these values. This is 4.58. Next column will be the quantity. And quantity will be mean area multiplied by chain length. So quantity in cubic meter. 6.35 multiplied by 30. So that value is now 190.5 multiplied by 30, this is 135.3. 0.83 multiplied by 12 because now the length is only 12. So this multiplied by 12 is 9.96. Now this is the part which is in cutting. So you can say quantity in cutting. So make one more column here. Now quantity in cubic meter in banking or in filling. So here you start 1.29 multiplied by 18 meter. So that value is now 23.2 cubic meter. 4.58 multiplied by 30, that is 137.4. So this is the total of these three values is in earthwork in cutting and total of these two values is earthwork in banking. You can add them. So this total in cutting is 335.76 and this is 160.6. This is in cutting, this is in banking. And why we are estimating these two separately? Because rates are different. Let us say the rate in cutting is 1,200 rupees per cubic meter and rate in banking is 1,000 rupees per cubic meter. Then you can calculate, you can determine the abstract of cost. You can prepare cost of abstract. Like this, that item number, details of the item, quantity, unit, price, and cost. So item number 1 is earthwork in cutting. Earthwork in cutting. Quantity is 335.76 unit is cubic meter. Rate is rupees 1200 per cubic meter, and therefore the cost will be 1200 multiplied by this 4,02,912 rupees. Item number 2, the earthwork in filling or earthwork in banking. The quantity is 160.6 cubic meter. Price is rupees 1000 per cubic meter, and therefore this is 1,60,600. Total 5,63,512.00. That is the total cost. You can add 5% as a contingency charges here, and that will give you the grand total cost. So add 5% as the overhead charges or contingency charges, and you get the total cost. So that is how we estimate the earthwork by mean sectional area method. In the next session, I will tell you the prismoidal method, which is more accurate than these two methods. Thank you very much for watching this video. If you have any question, you can write.